Good morning, students. I'm Amar Kudre here, and today we are going to discuss about significant figures. Before going on to the topic, I just want to ask you what is the use of life if it does not have any meaning. So the same thing applies in the case of figures, and so in a nutshell, we can say that significant figures are nothing but the digits which are meaningful. Okay, now let me give you a practical example of this. See, what I did was I had two oranges and I had weighed those oranges with the help of a kitchen weighing scale. Now, when I weighed it differently, as you can see over here, I got two different reading. That is, for one I got the mass of the oranges 225 grams, and for the other I got the mass of the oranges 220 grams. Now, normally what we will do is we will take the average of these two as the mass of the two oranges. So the average mass of two oranges will be 225 plus 220 upon 2, that would be 222.5 grams. Now here things are okay till here, but actually really speaking, that is, we are certain about these two particular figures, but however we are not certain about the other figures, that is either 2 or either 5. So in a nutshell, what we can say about significant figures are those figures of which we are certain of and including one uncertain digit. So those are significant figures. Here in this case of oranges, weighing of oranges, we can say that the mass of two oranges would be 222 grams. So it is these 22, that is the first two digits are certain and this is uncertain. So these are nothing but significant figures. So this certain, all the certain digits and one uncertain digit account for significant figures. So they, as I have told you earlier, that is those are meaningful digits. And in science, you all know that digits or numbers convey the story or convey the real quantitative measure of any particular physical quantities. Now you will ask me, okay, but sir, Amar sir, it is fine, but where do we use all the significant figures? Now, okay, just to give you an example, significant figures are important. Why significant figures are important? See, I had just taken a screenshot by putting the name Taj Mahal in the Google Maps. Now here is the location of Taj Mahal which I got. Now we all know that GPS receivers take the signal from GPS satellites which are orbiting around the earth, and GPS satellites are having atomic clock which are having the accuracy to around 1 nanosecond. So they can measure time accurately about 1 nanoseconds. Now what has been happening every time is a person having a GPS receiver who is on the earth, he or she is getting signal from this GPS satellite with a timestamp. Now the time required for that signal to leave the satellite and to reach the GPS receiver is been calculated. That is, we all know that this signal travel at the speed of light. So speed of light multiplied by how much time it took for the signal to travel from the satellite to the earth, that will give us this particular distance. So GPS is using significant figures in a very great way, and even if just to give you a brief fact, even if there is an inaccuracy of around 1 nanoseconds, then the position of us would be deviated by around a feet or so. So you can imagine how much accuracy we need to maintain regarding the signal from the GPS. Now, apart from GPS, we also have various pharmaceutical formulations or the medicine which we take. The medicines are having certain chemical ingredients in microgram, in milligram, and this we have to measure it certainly. So this is where significant figures come into play. Okay, I hope you are clear with this. Now let me share with you what is the concept map for today's session. What is the concept map and what are we going to study? Okay, firstly, what we are going to study is firstly the rules about significant figures, then what are the rounding of rules, and thirdly, what are the rules for arithmetical operations involving significant figures. So, this would be a very interesting way, and for the rules of significant figures, others would be explaining step by step, but here I have made a flow chart which is easier for students to understand. So let us go over to what are the rules for significant figures. So this is a flow chart which I had made. Now considering the rules for significant figures, firstly we will go over to the digits, that is okay, which digits we should consider. There would be certain digits which we got from measurements, then which of the digits should we consider. Now supposingly, now here in the first case, that is first rule, we have to remember that all non-zero digits are significant. That is, consider supposingly if we got the number as okay 1729, okay, which is my favorite number. Now okay, now one may ask, okay, how many significant figure does this number have? Okay, since all digits are non-zero, so we can say that this number is having four significant figures. It is as simple as that. Don't worry about it totally. And now coming over to 0, you can take any other number. You can take 6 to 5. 6 to 5 would be having three significant figures since all the digits are non-zero. Now coming over to the numbers which is having 0 in it. Now firstly let us divide those numbers into the numbers which are greater than 1. Okay, the numbers which are having 0 in it but which are greater than 1. Okay, now sometimes what happens is 0 comes in between two digits, two non-zero digits. That is, a 0 is trapped, a 0 or more than one 0 is trapped between two numbers. For example, let us say that is 100,065. Consider this particular number. Okay, then how many digits, how many significant figures are over here in this case? Now the rule for the trapped zero is all the trapped zeros between the non-zero digits are significant, so these become significant. So here in this case it becomes 1 2 3 4 5 and 6. So here we have six significant figures. Okay, so these all are rules for the numbers which are greater than 1. Now, what about trailing zeros? Now, what does trailing zero means? Okay, you all would be aware that is okay. The speed of the speed of the fastest train or the bullet train is around 400 kilometers per hour. So here in this case, this trailing zero does not convey much meaning, or there is much uncertainty over here. So in the case of significant figures, the trailing zeros are not considered. So we can say that only 4 is the significant figure. So we have one significant digit over here, which is 4. Okay, now okay, we will do more of these examples later on, and I hope things would be clear with this. Now consider what if we get 0 from decimal. That is, supposingly if the number is written as 653.0. Okay, then when we write decimal over here, then all the zeros which follow after a decimal, those are considered significant. So here in this case we can consider that as 1 1 2 3 4. It is having four significant figures. Okay, I hope these things are clear with you. Now we will go over to the numbers which are less than 1. Now, is there any special rule for the numbers which are less than 1? Yes, you can just think of supposingly if a number is around 0.0636. Okay. Now, here after the decimal, 0 is there after the decimal. So we should not consider this particular 0 which is coming before a non-zero digit as significant. So this particular number is having three significant figures. we can say. Okay, now the trapped zero, the rule for the trapped zero here for the numbers which are less than 1 is same as which was over here for the numbers which were greater than 1. Now, now what about the zeros if they are coming after a non-zero digit? Supposingly it is 7320. Now, in the case of decimal numbers, when we have a decimal point and the zero is been followed after a non-zero digit, then this is to be considered as significant. So here in this case, we have four significant figures. This is 1, 2, 3 and 4. This is four significant figures we have. This was about significant figures, the flowchart. I hope you are clear with this, and we will be doing certain examples with which the concept of significant figures would be very clear to you. Now, what is okay, now you all will ask, okay, what is this order of magnitude? Now, order of magnitude, that means in most of the cases, what we write is, we write numbers, that is the speed of light as 3 into 10 to the power 8 meters per second. Now, this is the order of magnitude when we express in the terms of 10 to the power something. Now, order of magnitude is never significant. So just forget about this thing. So even if it is a big number, we only consider that is 3 into 10 to the power 8 has only one significant figure. So that was it about significant figure. Let us do certain examples. Before examples, I feel that let us consider a few points, 2 points. First point is significant figure does not depend upon the system of units used. Supposingly, if we have measured a particular distance which is around 200 meters. So 200 meters, now if I ask you how many significant figures are there in 200, 2000 meters, you all will say, okay, yes, Amar sir, these three digits, since these three zeros are being followed by two, these are non-significant, so this is having only one significant figure. Now, if we convert this 2000 meter in kilometer, then it will be 2 kilometers. So 2 kilometers will also have one significant figure present in it. Now, secondly, the multiplying or dividing factors. Many a times what happens is we come across multiplication of certain significant figures, and wherein certain numbers or certain digits are there in such a way that they are multiplying or dividing factors. If they are not coming from rounding off, or if they are not coming from any other thing, or not from rounding off or not from measurements, then we can say that these numbers would be having infinite significant digits. Okay, what is the meaning of that? Supposingly, if you are considering the circumference of a circle, which is, we say that it is 2 pi r. Now, here in this case, a pi is having infinite significant figures, which we all know. And supposingly, if we have measured the radius of one particular circle to around two decimal places, say it is 123.45. So, and what about this 2? Now, here in this case, the 2 would be, it is 2 is having infinite significant figures. That is, or as the case may be, it is having infinite zeros. Okay, try to understand this. Now, we will do certain examples. Now, we are being asked to find out what are how many significant figures are there in the following numbers. Now, here in the first case, since 0 is been followed by is a trailing zero, so this is not to be considered. So only 1 2 3 it is, we have three significant figures here in this case. Now secondly, okay, now here is one trailing zeros which need not to be considered, but the second one is a trapped zero, so this is to be considered in significant figure. So we have 1 2 and 3. Again we have three significant figure in the second number. Now consider the third example. Okay, it is 50060. Now again, this is a trailing zero, this need not to be considered, whereas two zeros over here, these are trapped zeros which are to be considered significant. So the answer would be 1, 2, 3, 4. It would be, this would be having 4 significant figures. Now coming on to this question of point, now the numbers, for the numbers which are less than 1. Now, as I have told you earlier, that is the zeros which appear after the decimal point but before any non-zero digits are not significant. So we need to consider only significant figures starting from this particular number 5. So this one, and second zero is trapped zero, so this is also become significant. 8 is a non-zero digit, so this obviously is significant, and this zero which is followed after the decimal is significant, so it is having 4 significant figures. Okay, I hope you are clear with this. Now the number 1729.0, now this is having 1 7 2 1 2 3 and 4 along with a decimal, and if a 0 is been followed after a decimal, then that becomes significant. So we can say that this 1 2 3 4 5, this is having 5 significant figures. Okay, now what about this bigger number? Okay, now even if it is bigger number, let us stick to our rules of significant figures. This is one. This is significant. 1, 2, 3, 4, 5, 6, 7, and 8. So these are having 8 significant figures. I hope you are clear with this, and there is no doubt whatsoever regarding how to count the significant figures. Now let us go over to the next topic of what has been called as rounding off. Now rounding off you are doing since second standard, and I hope things are pretty clear with you for the numbers which are greater than 5 or less than 5. So now if we consider that as a number such as 3.624, now since now we have to round off till 2 decimal places, then how to round off this? Okay, now rounding off, that is we have to drop off a digit which is less than 5. So 4 obviously is less than 5. So how to drop it off? That is the preceding digit will remain the same here in this case, 3.62. So this would be the rounding off for this particular number. And if the number would have been 3.626. Now, if we have to drop off a digit which is more than 5, here it is the digit 6 here in this case. Now, what to do is, okay, you all know that is if the number which is dropped off is more than 5, then we have to increase the preceding digit by 1. So rounding off essentially includes 3.63. So this would be 3.63. Now, okay, now the real question comes when we have to round off a digit which is or we have to drop off a digit which is equal to 5. Now supposingly we will not consider 5 which is followed by 0, but we will consider a number in which 5 is followed by a non-zero digit. Now we will consider the same example, 3.6251. So now we have to round up this particular number to 2 decimal places. Now since 5 is followed by any non-zero digit, remember and listen carefully, 5 is been followed by any non-zero digit, then in that case the digit preceding 5 is to be increased by 1. So here in this case the answer would be 3.63 if we have to round it off to 2 decimal places, or we have to drop off 5. Now here, now the question comes over here. Now it is 3.625. There is no digit after 5, and we have to round off this particular number to 2 decimal places. Then what is the rule? Now in this case we cannot go by this rule because there is no number after 5. So what do we need to do is 5 followed by 0 or any other or nothing. Okay, 3.625. I'll repeat again, 3.625. So what to do in this case? We have to check what is the digit which is preceding 5. So here it is an even digit. So even digit, for even digit we have to keep the number as it is. So it remains like 3.62. If you have to round off to two decimal places. Now coming over to supposingly if the number would have been 3.635. Now here the number which is preceding 5 is a odd number. So in the case of odd number we have to increase the preceding digit by 1. So here the rounding off will be 3.64. I hope you are clear with this. Yes, and you are clear with the rules for rounding off. Now coming to the last part of the section, which is nothing but the rules for arithmetical operations for significant figures. So what are those rules for arithmetical operations? Now what exactly are arithmetical operations? That is the operations of addition, subtraction, multiplication, division or square root. So again we will divide these operations in three equal parts and we will study them. Now what about now first we will consider about the operations for addition or subtraction. Now here in this case first we need to add or subtract the digits as required, and then now and then check for the result. And here surprisingly over here, for in the case of addition or subtraction, we need not worry about how many significant figures are there. We only need to check how many numbers are there or how many decimal places. The number which is having the least decimal places, only that number we need to consider. So after adding 3.5 and 1.624, the answer is 5.124. Now here in this question 3.5 is having only one decimal place, so the answer should only include only one decimal place, so it would be 5.1. So the answer is 5.1. Since we don't need to round off anything, so the answer is 5.1. Now consider the case of 1.03 minus 0.3524. Now the answer over here which I've calculated earlier is 0.6776. Now here in this case, since the question is having two decimals, that is 0 and 3 after the decimal point, the answer should also include only two decimals after the decimal point. So here in this case, should the answer be 0.67? No. In that case, since the number 7 needs to drop off, so we need to round it off the second decimal place. So this is incorrect. So it would be 0.68. So this would be correct significant figure in the case of subtraction of two numbers having decimal figures. Okay, I hope you are clear with this. Now for multiplication or division, for multiplication of division, just remember that the quotient or the product, the quotient in the case of division or the product in the case of multiplication. Now here in the case of addition or subtraction, we were taking only the decimal figures, least decimal figures from the question. But here in the case of multiplication or division, we need to consider the number which is having the least significant figures from the multiplying or dividing numbers. So here in this case, so if it is 35.62 multiplied by 1.34, the answer is 47.7308. Now, in the first case, that is 35.62, we have four significant figures. Now, 1.34 is having 1, 2 and 3. It is having three significant figures. First, we have to carry out the multiplication as it is. Now, this is the multiplication. Now, how many digits should it have? It should have the digit which from the question which is having least number of significant figures. So it should have only three significant figures. So the answer would be 47.7. We should not include 3 over here over here, and since 3 is less than 5, there is no need of rounding off. So the answer is 47.7. I hope you are clear with this. Now coming on to square root. Now for square root, it is pretty much simple. That is, how many significant figures are there in the question, those many significant figures should be there in the answer. So for example, if the square root of 45.64, it is, we are having 4 significant figures. So the answer should also have 4 significant figures. So it would be 4, 6, 7, 5, 5. Since we need to drop off this 7, so since 7 is greater than 5, we need to round it off. So how will we round it off? It is 6.75, and this preceding digit should be increased by 1. So this would be 6.756. In the case of multiplication, let me give one simple example for multiplication. That is, we all know, that is, I was talking of GPS satellite and the accuracy. Now the GPS or the atomic clock which is there in the GPS satellite, it calculates time to the accuracy of 1 nanoseconds. Now here in this case, we don't need to, now here in this case, uh, if we consider the GPS has an atomic clock which counts to the accuracy of 1 nanoseconds. Now here in this case, we cannot afford to take the value of the speed of light as 3 into 10 to the power 8 meters per second, because here in this case the significant figures will be very less and we will really go haywire. We may go out of the location may go out of the earth also. So what happens is, we take the speed of light as 299,792,458 meters per second. So that is an up to an accuracy of around 9 digits. Then only we can have an accuracy up till 1 meter. I hope you are clear with this. And so this was all from me, and thanks a lot. I hope you got the concept of significant figures, how rounding off is to be done, and how mathematical operations need to be carried out. Thank you, goodbye, and take care.